Okay, in this lesson, we will go through periodic trends again, but we will talk about ionization energy and electronegativity. So let's see what is ionization energy means. Ionization energy is the energy needed to remove the outermost electron in an atom or ion in gaseous state. So the valence electron, how much energy is required to remove that electron is called ionization energy. So if low ionization energy, that means it is easy to remove an electron. If high ionization energy, that means it's hard to remove an electron. So the general equation is X gaseous state changing to X positive ion by removing one electron. So specifically, if you see magnesium changing to magnesium positive ion by removing one electron, the ionization energy is 735 kilojoules per mole. And Mg ion, that is the positive ion, changing to Mg2 positive ion by removing another electron, and the I2 is 1445. It is increasing when you go to the successive ionization energy. And now when it moves from Mg2 plus to Mg3 plus, it is again increasing. What's the reason? We know magnesium, the nucleus, first shell and the second shell, and Mg is 12, right? 2, 8, 2. So 2 electron in the outer shell. So when you remove one electron, this one, it needs less energy. After removing that, we have the same number of protons here, 12 protons. The nuclear attraction is more now. This electron is pulled by the nucleus more, right? So it requires more energy to remove the second one. And now you can see after that, second and third, a huge jump. This is very huge. When you see the difference here and here and compared with this second and third, it's a huge jump. The huge jump is because after removing the first electron and the second electron, the third electron is more closer to the nucleus. The whole shell is gone. The third electron is more closer to the nucleus and more nuclear attraction. So it's require a very high ionization energy. So by looking at the ionization energy, you can clearly predict how many valence electrons. So 1 and 2, not that big difference, but the third one is huge jump. So that means these 2 electrons are in the valence shell. You can notice the same trend in other groups for third period elements here. So third period elements are here in different groups. First group, second group, third group, 14th, 15th, 16th, 17th and 18th group. Okay, so these are all in the third period. So let's see the ionization energy here. Look at this one. Ionization energy is 498, the first ionization energy. And the second ionization energy is a huge jump. So what's the reason for that huge jump? Now you know. This is in the last shell. To remove that last shell electron, it's easy. And then it is going to the closer to the nucleus. When it going closer to the nucleus, so 281 for sodium. So this electron is getting removed. And then the nuclear attraction increases between the electrons and protons, and it requires a lot of energy to remove another electron from the second energy level. So that's the reason it's a huge difference, this one and this one. Okay, so now if you look for magnesium, you can see that we already explained that one, 736 and 1445, and then it is huge jump here. That means 2 valence electrons here. Okay, and now if you look for the aluminum 1, 2, 3, they are not that big difference, but when you go to the next one, look at the huge value here. So you can say 1, 2, 3 valence electron. That's what I want to say. And this is one of the type of question they ask in the multiple choice. Okay. So in general, as we go across a period from left to right, the first ionization energy increases. This is because the electrons are added in the same principal quantum level and the Coulombic attraction between the nucleus and outer electron increase, making it hard to remove the outer electron. So as we mentioned, so when you go across a period, the same energy level, Okay, nucleus and the first shell and the second shell. If you're taking the second one, nucleus, first shell and second shell, but the electrons are keep adding to that one. So 2, 1, and if you go to the next one, it will be 2 and 1 and 2. See that? So if the electrons are keep adding on the same one, means the protons are also increasing, right? The same distance, but you are getting what? The attraction more. So the size will decrease. So when the size decreases, what happens? You need more energy to remove the electron. That is why the ionization energy increases across a period. Nuclear attraction, Coulombic attraction increases. Okay, so when you go down the group, what is happening? When you go down the group, even though the number of protons are increasing, what happens is the shells are getting, more shells are getting added. Even though the protons are increasing, what happens is, see the shielding effect for the inner electrons. The inner electrons are here, and these inner electrons are actually shielding the outer electron from the attraction to the nucleus. Okay, it will shield it. And also what is happening is Coulombic attraction decreases, correct? That is what is happening when you go down the group. So what will happen to the ionization energy? It will decrease. Okay, so now I have some explanation on the exceptions here. Even though it is increasing across a period, if you note down the second group and the third group, what is happening here is second group is having S block, right? So S block means the shape of the orbital is spherically symmetrical. Whereas when you go to the P or 13th or third group here, P starts. This is P block, so it will be P1 here. So when the P starts means, see the shape of the orbital, the dumbbell shape. Let me get the pointer, the laser pointer. It's not coming. Anyway, so it is the dumbbell shape, so it is little away from the nucleus. So the attraction between the nucleus to this electron will be less compared to the spherically symmetrical S orbital. That's the reason if you go from second group to the third group, the ionization energy, it will decrease little bit because it is little far away from the nucleus, p orbital, because of the shape. Similar trend you can see from 5th and 6th. Why? Because the pairing will start in 6 because P1, P2, P3. We have 3 degenerated orbitals, that is equal energy orbital for P, Px, Py, Pz. Once it is half filled, it will start pairing. When it starts pairing, what is happening is electron-electron repulsion increases. So it requires only less energy to remove that electron. When somebody is quarreling, it's easy to separate them, right? So it is easy to remove that one. So that's the reason it is decreasing in between 5 and 6. Let me show you the graph. Here is a graph. This graph will show the exception in ionization energy in the third group as well as sixth group of elements. Ionization energy increases, and then for the third group it is decreasing, and again it is increasing, fifth group until fifth group or 15th group, and then it is again slightly decreased because of the electron repulsion. And here what you will do, the explanation will be S orbital, this one, and it is changing to P orbital here. That's the reason here. Now let's see what is electronegativity. Electronegativity means it's a measure of the ability of bonded atoms to draw or pull the shared electrons closer. Higher electronegativity means a stronger pull on electrons, or in a simpler way, how easily an atom attracts the valence electron to another atom. That is what is called electronegativity. The same trend as ionization energy. Let us see. Look at that one. Going down, the table, see, it is decreasing just like ionization energy, and along a period it increases. The same reason for ionization energy we explained. All these trends are actually opposite to the atomic size or atomic radii. So in more detail, increased number of energy level down the group increases the distance over which the nucleus must pull and therefore reduces the attraction. Also, full energy level provides some shielding between the nucleus and valence electron. So first shell, second shell, third shell, when you go, the first shell and second shell electrons will shield the outer electron from the nuclear attraction. So that is another reason it is decreasing down the group. Here is a concept check question. Predict the trend in radius for the following ions. And then read the second question and check your answer once you are done with this one.